Rewrite each expression as multiplication and determine the product. So we have 5 to the third power, which is 5 times 5 times 5. And the product, well, 5 times 5 is 25. And 25 times 5 is 125. Given the measure of two angles and one side, we can construct a unique triangle. Do you think this is always true, sometimes true, or never true? Well, yesterday, or in the previous lesson, we saw that 3 criteria wasn't always enough for us to create identical triangles. Like when we had 3 angles, we were able to create 3 angles that were the same, but the sizes of the triangles were all different. So do you think this is always true, sometimes true, or never true? I think that with 3 criteria, that this might be sometimes true. Today we're going to determine if a unique triangle or identical triangles will be formed when we're given 2 angle measurements and a side length. You can see here that there's 2 different types of setups. One, we have angle, and then the side, and then the angle, whereas the other one, we have the angle, and then the side. So the orientation of where that side is placed might change the outcome of whether we are able to create identical triangles or not. Consider the following line segment and 2 angles. Measure the line segment shown and label it with its measure. So we're going to measure this one in inches. You will need to use a ruler, and you're going to set this small endpoint on the 0, not at the end of the ruler, but the 0 mark, and then you're going to figure out where this piece lines up. According to your book, this is supposed to be 3 inches. On my screen, my ruler doesn't match up perfectly with 3 inches, so we're just going to trust that that is 3 inches. Then B says, use a ruler to copy each angle onto a separate piece of patty paper. So basically you're tracing these 2 onto tracing paper. And then that way we can move them around on our tracing paper. Do you think you can form a triangle with these 2 angles by using the side length given as the included angle, meaning in between these 2? So I'm heading back to that side length, that's 3, and I'm going to rotate my angle on the tracing paper and slide it so it matches up with this corner here. Then I'm going to take the angle on this side and again rotate it until this line lines up. And then I'm going to slide that over until it matches up with this side length. And then I can continue this line out from here out, following that same angle, and you'll see that eventually it will intersect. So yes, we are able to create a triangle with these 3 conditions. This phrase, included side, means that the side is in between the 2 angles. D, move the patty paper around to see whether you can form a triangle with the given conditions. When you have constructed the triangle, tape the patty paper to your book to show the completed triangle. So just tape it down in part A where you constructed your triangle. E, measure your triangle to make sure that the triangle you constructed has a side with a length of 3 inches between 45-degree angle and a 60-degree angle. So if we measure this side length here, it should be 3 inches. And we traced this angle and it was 45. And we traced this angle on our tracing paper and it was 60 degrees. So just make sure that you have all of that labeled in your problem too. Then F says, do you think your triangle is identical to the triangles constructed by your classmates? Well, it's possible that your classmates put the 45 over here and the 60 on this side. But that would just be the flipped over version of this triangle. We could reflect it like a mirror and we would still get the same triangle. G, copy the triangle you constructed onto a new piece of patty paper. Label the measurements you were given. So you're going to take another piece of tracing paper and lay it on top of the triangle and then sketch it on the new tracing paper. Then you're going to compare your triangle with a person around you, if you're in class or if you have a partner, and you're going to decide, are your triangles identical? Now, keep in mind, there might be slight differences just by the way that you moved your angles. Perhaps you didn't get it perfectly lined up and your partner did a better job, or perhaps your angles aren't all the way to the corners of those 3-inch line segment. So there might be some very slight differences, but when you compare them, your triangles should be nearly identical if the two of you performed the previous parts correctly. So therefore, they should be identical triangles. Consider the following line segment and 2 angles. Measure the segment shown and label it with its measure. So again, with your ruler, this time we're measuring it in centimeters. And again, my ruler on here isn't going to match perfectly to what's in your book. So it says that it is 5 centimeters for this line segment. Use a ruler to copy each angle onto a separate piece of patty paper. So you'll need 2 pieces, one for this angle on the left and one for the angle on the right. Then, do you think you can form a triangle with these 2 angles? And this time it says a non-included side, meaning that the angles are not going to be on both sides of the side length. They're going to be off to one side or the other. I do think I can form a triangle. So I'm going to trace those, and then I'm going to head back to part A to show you what it looks like. So we're going to line this up on the side, corner in the corner, and then we're going to take this angle and we're going to also put it on that side, lining it up with this red angle here, or this red ray. So let's see. I may need to extend the lines here for this angle to come out farther and adjust accordingly. So we want this angle to line up with this corner on the left. So we're sliding down the red line until this green line crosses with the black line. Like that. So this was the 110-degree angle, and this was the 50-degree angle. And since it's a non-included side, so that 5 centimeters is not between these two angles. D says move the patty paper around to see whether you can form a triangle with the given conditions. When you have constructed a triangle, tape the patty paper to your book to show the completed triangle. So tape down these two pieces of paper into part A. Then E says measure your triangle to make sure that you have constructed a 50-degree angle, a 110-degree angle, and a non-included side length of 5 centimeters, which we have done. Then it continues with F. Do you think your triangle is identical to the triangles constructed by your classmates? So again, it's asking you, do you think that this triangle is the same as your peers? And so this is a question that's up to you. You decide, do you think it is going to be identical to others or not? And write that down in F. So 3F. At this point, F is just an opinion. So we don't know for sure. We haven't checked with our classmates yet, but we're just trying to determine, do you think it would be identical or not? So write a statement here for F with your opinion. G, copy the triangle you constructed onto a new piece of patty paper and label the measurements you were given. Compare your triangle to the triangle your partner constructed. Did you construct identical triangles? So G is just trace that triangle again. And H, we are comparing. Did you get the same triangle as your partner? Since you are virtual and not in person, if you don't have a partner, I'm going to show you a different way that we could have arranged these. So I have the 50-degree angle here and the 110-degree angle here, creating a triangle that looks like this. Now, I'm going to rearrange it so that the 50-degree angle is here and see if it creates a different triangle. So here's a triangle that can be created if we used the 50-degree angle first and then the 110. So is that the same? Are they identical or are they different? These two triangles appear to be different. So in part H, where it says compare your triangle to your partner, did you construct identical triangles? We're going to say no, that two different triangles can be created depending on the different positions of the angles. Now, through this exploration, we have shown that we can construct two triangles with the two given angle measurements and a non-included side. That's the key phrase here. And these conditions did not guarantee that we were going to make identical triangles or unique triangles. My recommendation is that you go back to the graphic organizer from the previous lesson and add these criteria to the how many triangles page. When were we able to create one triangle? And when were we able to create more than one triangle? Check back for lesson 8. It should be posted soon.